Okay. Here's number 3. We don't have a calculator anymore. Let's see what they got going for us. So we got a student reading books at times 0 minutes. They continue reading for the next 10 minutes. Good for them. A book. The rate at which the student reads is modeled by R, and R is measured in words per minute. We're paying attention to that. That's the rate of change. Calm down there, phone. And we've got, so dude, my phone is going nuts. Let me get out of here. Silence this. There we are. Okay. So, RT is given, approximate R prime of 1. We saw a bunch of these in the last few years. Hopefully you said R prime of 1 is approximately equal to R of 2 minus R of 0 over 2 minus 0. I think you should have wrote that out like that and then plugged in the numbers. That is 100 minus 90 over 2, and that's 10 over 2, and that is 5. Okay. Going quick here. If I make a mistake, forgive me. But I feel pretty confident about this one. That's since that's R prime. It says here, it told me to do this. Okay, and show the work leads your answer, indicate use a measure. So R itself is measured in words per minute. And then we're dividing it by minutes again. So you should say words per minute squared. All right. For B. Must there be a C where R equals 155? Well, this is 100% intermediate value theorem. Because they gave me a table for R, and they said, hey, does R have to equal this? So, does it have to go through 155? Absolutely, because it goes from 150 to 162, and I know R is differentiable, which means it's continuous. So I'm going to say that, okay? Since R, oh my gosh, since R of t is differentiable, R of t is continuous. Okay, and I might write something like, so intermediate value theorem applies. Since R of, so we want to say it goes through 155, so we got to use these numbers here. So R of 8 is 150, which is less than 155, which is less than whatever this next number is, 162, which was R of 10, I believe. R of 10. There must be a time C such that R of C equals 155 words per minute. Okay. That's pretty good. Use the trapezoidal sum with 3 subintervals to indicate the approximate value of this integral. They don't even ask me what it means, so that's fine. I'll do it right here. So part C, the integral from 0 to 10 of capital R of t dt is approximately equal to, we need 3 trapezoids. So the first one is 1/2 times. The height is 2, that's coming from here. And then the bases are 90 plus 100 plus 1/2. The next height is from 2 to 8, that's a height of 6. And they have 100 to 1 and 150 bases. Plus 1/2 times 2 again, 8 to 10, that's right here, boom, 8 to 10. So 1/2 times 2 times these next bases are 150 and 162. Okay, and that's 3 of them right there, boom. And the units on the integral of this, since R is in words per minute and dt is in minutes, this is going to be words. Okay, and you do not need to simplify that. If you did simplify it, let's just do it real quick. This is 190 plus, this is 250 times 3, which is 750. And this cancels out. So this is, what is this, 200, 312? Is what that looks like, right? Yes. If you put all of this together, this is a pain, but this is 400, 502. That's these two together, make 502. If you add that to 7, it's 1252 is what that looks like. And this is me rushing here. But that's what I think we should have got there. All right, so it's part C. And then part D. which we'll do over here. Let's do it in blue so we can see the difference between these. Part D, a teacher also starts reading at this time. How nice. And they continue reading for 10 minutes. Great. The rate at which the teacher reads is modeled by the function W, okay, and W is still measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Well, since this is words per minute, then the integral of that from A to B will be the number of words, which is what they asked me to find. So I need to do the integral from 0 to 10 of this thing. And yeah, this is not a super hard integral. It's just the power rule, but lots of chances to mess up some arithmetic here, which we'll see. So I think you get points just for showing you need to integrate this. If you calculate the antiderivative, this becomes t cubed. You got to divide by a 3, so that becomes that. This becomes t squared divided by a 2, so this becomes a 4. And this becomes 100t, and that is from 0 to 10. Okay, I think you get a point for that antiderivative probably, so good job if you did that. We got to plug 10 in. So this is going to be 10 times 10 times 10, but we're also dividing by 10 here. So it's really just 10 times 10, and it's negative, so that's negative 100. You could also plug into this and not simplify it at all and still get full credit for this as long as you put units on there. When you put 10 into here, that's 100 times 4, which is 400. And when you put 10 into here, that's 1,000. Not that, there you go. And when you plug in 0, you get 0. So we got that going on. So this is 1,300 words, which I did hear some of my clown students talking about it, my very good students, talk about this answer today. And they said, hey, we got 1,300 for something. So hopefully it was this one.